Okay, we continue with Chapter A, Section 8.4, using separate parallel server. In the written and eye exam tester station used to have a capacity of 3, but we want to simulate each one of the testers take a break every 8 to 12 applicants or serving after they serve 8 to 12 customers. And also we're using a failure mode based on count, process count. So in this case, we need to first separate the tester section with a capacity of 3, change to 3 different tester section, each with a capacity of 1. And we see this is how it looks like afterward. And also, we don't want the customer to, the applicants to wait in the server input buffer. We want them to wait on, at the output buffer of the registration area. So this is what we do. Actually, we want them to wait in this registration area. Let's see what kind of behavior is that, and then we move on to using a selection rule to forward the entity to the lowest station low in this tester. So let's take a look how we're going to do this. And this is the model we have from 8.3, and then we starting to modify this. First, we change the capacity to 1 and make a copy of 2 section. Down here. So this is we call this tester 3 and tester 1. I'm going to call this guy tester 2. Okay, and each have a capacity of 1 in that case, and also want to make a path moving from registration to tester 3, registration to tester 1. Again, I'm going to connect the output node from tester 3 and tester 1 forwarded to the output node of tester 2, so I can make a decision that way. So just simply use the connector here, connect it to tester 2, and connector, simply connect it to that. Okay, so I can, based on these, just continue, show this path, and this is just continue. Here we have 3 different paths. I'm going to set their distance to 5 meters altogether. The thing is, I don't want them to wait in this area, so we're going to set their input buffer from infinity to 0. So I'm trying to not allow them to come in that way. And that's what we're trying to do is after they come out of the registration area, we want them to direct to each one of the tester based on their station low. We did this before. Let's redo this again. We create a list. It's a list of a node. Called a list of tester. Okay, and their object type is node. Going back, here. I want you to see that instead of using entity outbound logic, if the continues, I'm going to select from the list, and from the list of a no tester, and selection go is using the smallest value for so-called candidate. We've done this before. A no associate station load. Okay, we've done this before. And also these three tester has a specific value pattern. So in the reliability logic, instead of no failure, we're going to do a process count based on uniform distribution between A to 12. So A to 12 applicants or customer, we take a break, okay, on the average. And also, each break is going to take 2 to 6 minutes, most likely 4 minutes. So it's going to be per distribution, 2 to 6 minutes, and most likely 4 minutes, just for example. And make sure these are, the time units is minutes. Okay, so couple changes for this tester server. Input capacity, input buffer capacity equal to 0. Each one of them has failure rate. And also I want to pay attention is once these are failure, we don't want them to come in to the server. So what do? Is we come in here to change the so-called block destination selection condition. Expression, sorry, I had it wrong place. Selection expression is association load, and select condition will be select only if the candidate no server is not in the failure situation. So I'm going to not first candidate server is failure, is not failure, and failure is not active. So if it's active, I'm not coming in. If it's not, I'm coming in. Okay, so this is what I do. And I want to select only the available only. And so this is what I have set up for it. So this transfer node, I'm going to select tester 1, tester 2, or tester 3 based on the lightest load, overall load. The station load stated over here represents the number of part en routes to the station, number of part waiting in the input buffer, number of applicants are currently in process, these three added together. And that represents the so-called the server station node. We choose the smallest one, and also the selection condition only if the currently server is not in the value situation. Let's run. All right, we start running this model and see what happened. And you see this part is waiting in the outbound situation. Only if they coming into, actually I can zoom in a little bit, see this is the outbound section. And also want to specify, and if the server is in the active mode and also server is not currently in the busy situation, I will let this I will let the parts go in. So here in this node, I'm going to do that, and also the candidate, I'm going to do this using this instead of, and the candidate node server, okay, server, candidate server, and resource state is not equals to 1. So the 1 means it is busy. So the server is not busy. I'm coming into the situation. So rerun this, see how that's going to go. Evenly distributed the applicants to different tester section. If I have too many, it should stay in this output buffer. I'm going to line it up a little bit so you don't see them coming in. Okay, you see the entity is accumulated in the output buffer instead of the path. We're going to conclude this 8.4 section, and we continue more advanced tweaks on 8.5.